Thanks for being here. It's really exciting to kick off the Chicago Summit. I was here at the summit last year, and it's really exciting to see how much it's grown and really how much this area in general, if I look across the schedule, how many big data related sessions there are. When I joined AWS about 3.5, 4 years ago, it was in some people's minds, but it was still early days. And now you have companies across the spectrum and so many different market verticals and horizontals actually using it in their businesses every day. It's not just something that a CTO told you to look into. It's now a core part of many businesses, and many businesses that have been quite surprising, quite honestly. At the beginning, we saw a strong uptake from a lot of healthcare life sciences and financial services companies, and the kind of people you'd expect to have a lot of big data. And now we're seeing it across the board. You know, there was this big uptick in advertising and marketing, and now we have pretty much everybody. You know, from the gaming to design and engineering to healthcare life sciences to financial services to media and entertainment. The ability to analyze a lot of data at scale and to do it quickly is becoming increasingly core to all of our businesses and just to life. You know, we all have a lot of personal data too, and the ability to mine that data is actually interesting in itself. So what we're going to do today is talk about getting started. Talk about building your first big data application. This may or may not be the first time that you have built a big data application. It might be for some of you. So we'll touch on some basics, but we'll also go a little deep. And my intention here today, I've done variations of this talk for a few years now, and what I've realized is that never underestimate people. People can go, even if they've never done big data, or even if they're not coders, can actually go pretty deep, pretty fast once they get excited about it. So I'm here today to try and get you excited about big data. So before I go any further, my name is Matt Yanchishin. I lead the solutions architecture team. Don't worry about the last name, just call me Matt. I lead the solutions architecture team for AWS's software partners. I've done a lot of big data stuff, a lot of media and entertainment stuff over the years. Been with AWS for a while. And I'm very excited to do a live demo with you early in the morning. It's really a bad idea. Ask anybody, especially solutions architects. They all say the same thing. Make sure you record it. This is not a recording today. We're going to do a live demo. We're going to build an application together in real time. The whole point of today is to give you something that you can take home and try again. You can do this whole application that we build today for just a couple bucks, if that, on your own time in your own AWS account. And in fact, you could do an enterprise-grade version of this for much, much greater scale. Today, we're going to deal with I think it's about 32,000 lines of logs or something. That's all we have time for in 45 minutes in terms of loading. But you could easily extend this architecture to be 300,000, 3 million, potentially 3 billion rows of anything. And that's what makes this whole thing kind of exciting, is that this presentation is designed to scale, and it's designed to be take-home. So it says it comes with a take-home lab. The take-home lab is actually the slides. Everything that is on the slides is all you need to build your application today. So there's going to be a little bit of code on the screen. There's going to be some Scala on the screen. But even if you don't necessarily want to care about Scala or Java, that's OK. You don't need to understand much. If you understand how to write a basic regular expression, a simple transformation, you can do everything that we can do today. You can launch clusters. And one of the most exciting thing for me here is thinking back 4 or 5 years ago. Like I said, I came from a media and entertainment background. We had a lot of transcoding clusters, and even firing up clusters of 10, 20 nodes was a big deal. It required a lot of people, let alone Hadoop clusters that were doing MapReduce and big data processing. We're going to fire up data warehouses that are enterprise grade. We're going to fire up Hadoop clusters in just a command or two, and we're not faking it. That's how easy it is. And hopefully that's your takeaway from today. If I do my job right, the takeaway is that yes, I can do this too. I can extend this for my own uses, and that really in 45 minutes, I can build something useful that can help me solve a business problem. So I always like to level set when I'm talking about big data. You know, what is big data? It's an overused term, that's for sure. Your big data is not my big data. Big data is not necessarily size. It can be complexity. It can mean any number of things. For me, big data, all it means is that it takes a lot of creativity to unlock the value inherent in that data. And creativity can be in the form of code. It can be in the form of tools. But the interesting thing about big data, and as things have evolved, certainly since I joined AWS, is that the tools change, but the patterns remain eerily similar. One thing I have seen recently is that streaming data is now a much bigger deal, much more important, real-time reaction. And so we're going to talk a bit about real-time today. But fundamentally, this is what you have to do. You know, you have to store data in ever-increasing amounts, and you have to derive value from that data in some way. So you have to collect it such that you can store it. And then you have to be able to process it. Sometimes you have to normalize it, like if it has to go into a relational database that's highly structured. Maybe you don't have to normalize it, but you need some way to analyze it ultimately, to extract that data. And if you've ever taken a MapReduce output and shown it to your CEO, you'll know that that doesn't go over too well. They want to see a nice, pretty graph. They want to see something on Tableau. They want to see a nice visualization that allows someone to reach an insight about what you're trying to show them very quickly. So visualization is actually very important, and it's an art. To take the output of that big data processing and to make it not simplify it, but to create value, to give an insight in a visual way is actually really hard. So visualization is a key part, and we have QuickSight now for that, and we have a rich partner ecosystem for data visualization as well. So we're going to talk about Amazon S3, which is our object storage service. That's where we're going to store all the data. S3 is an amazing place to store data because of a few reasons. It's really cheap. You can store as much as you want. And it has a lot of different tiers. So depending on how quickly you need your data, you can store it at different tiers. If you don't need it that quick, you can store it in SIA. If you need it once a year or maybe never, you can store it in Glacier. If you need it right away for very fast, very scalable big data processing like today, you can store it in the standard tier of S3 and have access to that data at scale for many different applications simultaneously. It's a very, very flexible, very, very affordable place to store really anything. Today we're going to store lines of logs, but it could be really anything that's bits you could just stick in S3. Collection is something that was historically hard. It's easy to say, yeah, just store it in S3. But the question we used to get a few years ago was like, okay, yeah, you said that, Matt, but now I have to write all this software and deploy it to my whole fleet and push it up to S3 and keep track of whether things made it there or not. So that's why we came up with Kinesis, and more recently Kinesis Firehose and the Kinesis agent and the ecosystem around Kinesis. For anyone who's ever grappled with Kafka and setting that up, you'll know that it's not trivial. You have to usually hire someone to do that, and that person is expensive. So Kinesis makes the collection and the storage or buffering of data, certainly streaming data, such that you can then persist it into S3 really easy. Then, of course, processing. A lot of people will ask, well, what's the difference between Elastic MapReduce or EMR and Redshift? Why would I need one or the other? Can't you do sort of data warehousing now on EMR? Why do I need Redshift if I have EMR? Can't you do data transformation on Redshift, then why do I need EMR? I've really always seen them as really, really complementary. Redshift is your enterprise-grade data warehouse that allows you to do really serious sort of hardcore analysis. It works really well with an ecosystem of BI tools, of visualization tools. It's SQL. Anyone who's ever worked on any kind of a SQL database, a relational database, a data warehouse, sort of immediately inherently understands how to use Redshift. So you can use existing resources in your business or existing knowledge that you may have, and it scales really, really well. It's rock solid. EMR is almost like an operating system for big data. It gives you a little bit more flexibility. The data doesn't have to be as structured going in. Redshift works in tables. It works in SQL. You have to know ahead of time what your data is going to look like. But the thing with streaming data and big data is, what if there's glitches in the data? Or what if you're collecting data from a lot of different sources, and that data is in a ton of different formats? What if your data changes over time? What if you acquire some company and their data collection is storing in a totally different format? Or what if people are people and they just make mistakes, and you need to normalize the data or modify the data or just handle a variation of data formats? That's where EMR comes in really handy. And when I said it's kind of like an operating system for big data, I say that because inside of EMR, you can run a number of different processing engines. So Redshift has its Redshift processing engine. It kind of looks and feels a little bit like Postgres, but it's our own thing. Whereas with EMR, you can run MapReduce, you can run Spark, you can run a number of applications within EMR and do it at scale. And so as trends change, and we'll talk about this in a little bit, you can adjust and without having to change the common platform that is running your cluster. So EMR, think of it as a cluster management tool, as sort of a place like Hadoop and EMR are an operating system that run a number of big data applications that will be suited for individual needs. And then Redshift is kind of the final destination to do your sort of deep dive analysis. In this case today, we're going to use QuickSight to analyze data in Redshift. We're going to use Spark running on EMR, on an EMR cluster, to process that data, to do some data normalization. We're going to use Kinesis and Kinesis Firehose to take data from logs, to bundle it up such that it's efficiently stored in S3 and is also more efficient to iterate over. I'll talk about that in a little bit. And we're going to use S3 as kind of the thing to tie the room together. It's the single place to store all the data. It's a great place to sit at the middle of any sort of ecosystem of big data tools. I didn't really touch on that, but for me, that might be the single best reason to use S3 is that so many tools these days, whether it's Spark or Redshift loading from S3, or Kinesis being able to persist S3 with Firehose, and a number of ecosystem tools around the world. They can all work with S3. So it's a great sort of single source of truth, the center of your data world, onto which you can bolt a number of tools for different use cases. So what actual problem are we going to solve today? Well, really kind of a simple one. We're going to mimic web logs, a fleet of web servers. Many of us have mobile applications or web servers. So we're going to sort of imitate having a server or a bunch of servers all pushing Apache HTTPD web logs up to S3, or in this case, up to Kinesis, persisting that into S3, processing those logs, because we don't need all the information in the logs. I don't know if any of you come from an advertising background and if you've ever seen an Omniture log, for example, but it has it's an insane amount of columns, like 99% of which you don't need. So rather than create all those columns and then have to deal with all the overhead, you can use a tool like EMR to parse out the data that you want on the way in. And then we're going to put that data into Redshift, and we're going to analyze it using QuickSight. Now, QuickSight is not generally released yet. Well, I don't know if it will be at the keynote or not. We'll see. But you'll get a peek into what QuickSight looks like and how easy it makes data visualization. So let's do it. I said I was going to do a live demo. I wasn't lying. Again, everything in the slides is all you need to build the big data application. And what we're going to use today is the command line tool. Now, I could have been clicking around the management console, but that's, well, I guess it looks prettier, but it's not really how you work once you get rolling with AWS. The command line tool, the AWS CLI, is a very efficient way to interact, to spin up and spin down resources. It's really kind of a thin overlay on top of our API. So I'm going to use the command line tool to do things like spin up EMR clusters, to start your Redshift clusters, even to work with IAM. So the commands you're seeing today are all part of this one tool, the AWS CLI. You can download it now if you want. And that's what we're going to use to do pretty much everything. I'll go into the console to kind of prove to you at different points that I am actually doing a live demo and there's data flowing. But that's really all I'm doing. You could do this entire demo using the command line, except for the visualization part at the end. So first thing we need to do is create an Amazon S3 bucket. And you'll notice that I put all of the steps for the command line, so you don't have to do copy-paste from PowerPoint. We need to create an S3 bucket to hold our data. So again, S3 is an object storage service. It can store pretty much anything. And this is the one step I did do ahead of time, because I was worried that someone would take my bucket name in the time that I was getting set up. But either way, to create an S3 bucket, it's a really simple one-line command, or you can go into the console and create a bucket. You can think of a bucket kind of like a folder that can hold objects, and objects are essentially files. So S3 is a place to hold files or objects in a big bucket. And one common misperception with S3 is that there's sort of subfolders. That's actually just a UI trick. When you put a slash in your object name, on the UI, it shows up as a folder. So if you have like mat/big/data, it'll show up as like cascading folders down. But in fact, that's one object name called mat/data/. So that's just when you're doing a list, you'll see that we also parse by folder just to make it easier to understand. But in fact, those are just single objects hanging off of your S3 bucket. So we're going to create a bucket to hold objects. In this case, the files are going to be logs. Now, the thing with S3 to keep in mind is that having a ton of little files is not necessarily a great idea for a lot of reasons. If you look carefully at the pricing, you pay for the API actions. It's a tiny, tiny amount of money. But if you're doing billions and billions of gets, that can add up. Also, if you're loading data into Redshift, and we'll talk about this later, it's not efficient for any database to do 1 million writes into the database. What's much more efficient for databases like Redshift that's supported is to aggregate those logs, like log lines in our case, into little bunches, and to essentially batch it into EMR or into Redshift. With EMR, same thing. If you're using Hadoop, MapReduce, or Spark, it's much more efficient to process chunks of data than it is to process individual log lines. You can think of any distributed system. If you have to spin up a new process to process one Apache log line, it's not really efficient use of resources. There's overhead associated with doing things, so it's better to batch things up. So what we're going to do today is actually take those log lines, batch them together into little 1 megabyte or so chunks. It's actually a little bit smaller. And we have those chunks sitting as gzipped or compressed files in S3. So I said we're going to use Firehose. So what's Firehose? You can really think of Kinesis like a queue or a buffer. If you have a bunch of servers writing web logs, It's fine to write them all to S3, but it's much better to be able to batch them, for example, into S3 and to compress them. Having an intermediary, to decouple yourself from writing directly from S3 gives you a lot of flexibility. You can have a number of different sources streaming into S3. And also we have tools associated with Kinesis called Firehose. And Firehose, what it does is it takes care of that hard part. It takes care of that batching. So it'll send it up to Kinesis, and then it'll batch things for you, compress it in the format you want, on a time interval that you want, or the file size that you want, and then go and persist into S3. So think of Firehose as kind of a tool that associated with Kinesis that allows you to push into this buffer, this intermediary in front of S3, do some things to your data into Kinesis, and then persist it in its final resting place in S3 in the format that you need it. In this case, we're targeting about a 1 megabyte gzip chunks, and Firehose takes care of that. So Kinesis allows you to decouple your application or your thing spitting out data from the place where you actually want to persist it. Another reason you might use Kinesis is maybe you want to persist data in a number of places. Maybe you have different applications that require different types of data stores. Maybe you want to persist in an S3. Maybe you want to pull data somewhere else. So putting data in that intermediary decouples you from the place where you're ultimately persisting it. And if you're going to hear people say decouple a lot at this summit, it's really important to always think of how can I separate the components of my application to give me greater flexibility. So the reason why we have IAM here up on the screen is because we need to give Firehose permission to write to that bucket. So we're going to be writing to Kinesis Firehose, and then Firehose needs to have permission within the account. Remember, we lock everything down. Services can't just write to each other arbitrarily. You have to explicitly opt into that. So we're going to say, hey, Firehose, you're allowed to write into this S3 bucket. So when I push stuff into Kinesis Firehose, it can then persist in and write objects into S3. So we have to make that explicit. So that's what these two steps are. If this looks like JSON, it is. That's an IAM policy for an IAM role. And a role, whether it's for EC2 or for Firehose, is just a set of permissions that a service or an instance assumes. So in this case, Firehose is assuming permission to write to S3. This is only something you have to do once. You can give it access to all of S3 buckets if you're testing within your account. But in a production application, you want to be a little more granular. You don't want like your logs to end up in an S3 bucket with production data that it shouldn't touch, for example. You want to segregate your data. So this is why roles are powerful. It allows you to be very explicit about what can write to what specific buckets, or even what prefixes, what subfolders, if you will, within those buckets. So policies are a really powerful way of segregating your data and adding data security to your stream. So let's do it. Let's create a role. Oops. So can you guys see that at the back? If you can't, can you raise your hand? Okay. So we're going to be at a console. Hopefully you can see that okay. It's not really important that you see the details of the console. It's more just to show you that I'm actually doing a live demo. In this case, I'm going to use the CLI to call the IAM and to create a new role called Firehose demo and to assume the policy that I have in a document on my laptop that you just saw on the screen. That's a JSON file. That's it. And it spits out just a confirmation with an identifier, a unique identifier for that role. So next I'm going to add a policy. And remember, now that we've given Firehose a role, we need to give it a policy. You are allowed to write to this bucket. So I'm going to give it a policy that's going to write to a bucket called, I think, AWS MYAN Chicago. I think that's the bucket that I created. So it's going to give explicit policy, or permission rather, to Kinesis Firehose to write into that bucket. That's it. All right, so now we're all set. So Kinesis Firehose, which again, think of it as this intermediary, this buffer, this queue, where we can push our log data, our streaming data, and then it takes care of that batching and that compression before persisting it into S3. This will make more sense in a second. So now we're going to create the Firehose stream. So we use the term stream for a Firehose, and this is a place where we're going to send our Apache weblog data. And you could have a fleet of 1,000 servers across multiple availability zones, across multiple data centers, and they can all push data into your Kinesis stream. And when you push it into Firehose, it gives you that added flexibility, that added tooling to do things like aggregation and compression, et cetera. So we're going to create a stream. We're going to create a location where we can push this data. So if you look at this command, oops, create delivery stream. In this case, I'm going to push it into this bucket called MEN demo Chicago. That's the calling out to the role. This is the permission that it's going to inherit so that it can write into this bucket. And this is the important part. This is the part that I want you guys to get. Well, three things really. First of all, when it writes to S3, it's going to put a prefix that says Firehose /, so it'll look like a folder just to keep things separate in case there's other things in the bucket. It's going to buffer things every 60 seconds. So as I'm pushing tons of stuff up to Kinesis, it's going to wait 60 seconds, batch up all those things in the 60 seconds, compress it using gzip, and then every 60 seconds push a little chunk into S3 so that we can more efficiently work with that data out of S3 later. Whoa, I'll already use this. Next, we're going to process the data. Well, I guess we'll push in the data first, but this actually takes some time. So let's do this first. Let's create a cluster. So this is where things get exciting, especially if you've never done big data. We're going to create a Hadoop cluster. So just returning to EMR for a second, EMR is essentially like a cluster management tool that runs Hadoop. And Hadoop, you can kind of think it in combination with EMR like an operating system for big data applications. In this case, we're going to install a few applications on our EMR cluster. We're going to install something called Hive, which is an oldie but a goodie. It's something that allows you to process and view and interact with your data using a SQL interface. And in fact, when you write SQL, it takes that SQL and translates into MapReduce jobs, or in this case, into Spark jobs. We're going to install Spark. Most of you will have heard the term MapReduce, and some of you may know the term Spark. Others may know the term Flink. This is a fast-changing space. I've been giving the Big Data Bootcamp for a few years now, and the tools that we use in the bootcamp change every 6 months to 12 months. But the patterns stay the same, and quite frankly, the fundamentals stay the same. What Spark is really an execution engine, a processing engine. You can think of it like a next generation of MapReduce. MapReduce is amazing. It opened up batch processing workloads to a whole world of people in sort of a commoditized way, but it was slow. And Spark uses a bunch of techniques like in-memory processing and a bunch of other techniques to run faster. I'll talk more about Spark in a second. And lastly, we're going to use something kind of cool that's pretty new on EMR called Zeppelin. And Zeppelin is a web interface. If you've ever used EMR and you're not that comfortable with Linux or the command line or just coding in general, it's a bit of a sharp learning curve at the beginning. So what Zeppelin does is make that a lot easier. You have a really nice web UI that allows you to execute Spark commands, Hive commands, SQL, and really interact with your data on your cluster without having to like SSH into it and do a bunch of crazy stuff or look at output on a console, which is not easy sometimes to interpret, especially when you get a big fat error and you have to sort of scroll up in a console, not the best user experience. So Zeppelin makes that easy. So we're going to install 3 applications on our EMR cluster and spin that up right now. This is a 2-node, just a small 2-node cluster of an M3 extra large, and we're running the latest EMR distribution. Okay, so there's the cluster ID. Now that one command is going to spin up an EMR cluster. I could have put 2.0 and had a 20-node Hadoop cluster. And what's really cool about this is that if you look at our console and go to EMR, you'll see that it's already starting. And in about 2 minutes, you'll have a Hadoop cluster up and running. We'll come back to it to actually show you that it really is 2 minutes. But this is wild. If any of you ever worked on premises in a data center and had to rack and stack and set up a Hadoop cluster, you'll know that it didn't take 2 minutes. And for me, when I joined AWS, this was certainly a big eye-opener. But let's get ahead of ourselves and come back to that so we're not wasting too much time. So now that we've set up an enterprise Hadoop cluster for data processing, we're going to do step 2. Let's set up an enterprise-grade data warehouse. Easy, right? Well, it is. I don't know how many of you have, on-premises, tried to set up a data warehouse, but again, I did once in my old job, and it's hard. It's hard to get right. You have to do a lot of tuning. There's always going to be optimizations and tuning after the fact for your queries and your schemas and your tables. You know, that's actually what we pay the guys in the white lab coats for. But the cluster part, the infrastructure part, AWS takes care of that for you. So in this simple command, we're going to spin up a data warehouse, a Redshift cluster. In this case, we're doing a small single-node cluster. But again, this could be a multi-node, very large data warehouse capable of storing petabytes of data if you wanted to. What we specify here is just the type of node, there's different types of Redshift nodes that you can read up on, whether you need more relative CPU to storage, or if you're more concerned about storage. It's just a classic sizing exercise based on the kind of data you're processing. In this case, we're going with a simple DC1 type and a single node. So let's spin that up. Okay. So let's go back to the console for a second, see how our Hadoop cluster is doing. So this is still provisioning. What it's doing is firing up EC2 instances. It's provisioning those 2 instances. I'll make this a little bigger for you guys. And it's going through the steps. And what steps are is it's installing those applications. It's installing Spark. It's installing Hive. It's installing Zeppelin. If I go over here to our Redshift console, you'll see that my cluster is starting to fire up. It's creating, and if we come back to this in a minute or two, we'll have a Redshift cluster up and running. Okay, so now that we have our thing to process the data, and we have Firehose set up so we can collect the data, and we have Redshift set up so we can analyze the data, we actually need some data to play with, right? So this is the one part of the demo that's kind of fake in the sense that I wasn't going to have a fleet of web servers pushing up web logs. But I did want to show you something real. I didn't want to take an existing data set. So what we'll do is I'm going to take a very big web log and push it in real time line by line, sort of imitating a fleet of web servers. So in this case, it's just 32,000 lines, which sounds like a lot, but it's also not that much. But we're going to push all of those 32,000 lines during this demo up into Kinesis Firehose and then eventually into S3. So you can push data from logs in a number of ways. There's the Kinesis agent, which is probably the best way to do it. But in this case, because I'm using a flat file, the fastest way for me and for you guys at home was just to use a little Python script. So those, whatever it is, like 10 lines of Python, it uses Boto, which is the same Python framework that our CLI is built on. And it's, even if you don't speak Python, this is pretty easy to understand. It opens up a file called weblog in read-only, and it puts records into Firehose line by line until the file is done. So this is effectively imitating a fleet of web servers that are taking web traffic, and it's putting those log lines, those Apache logs. And I whipped by it. Let me just go back to this. This is what the Apache logs look like. So there's a bunch of data in there, the public IP address of the host, the time, what they're trying to get, like a web page or a fave icon or whatever, what the code was, if it was a 200 OK or a 404 not OK, the user agent they were using. So if you're in advertising, or even if you're anyone and you run a business, there's a lot of data in here that is interesting and useful to you. Potentially, you can tie the IP address to the geographic location of where your visitors are coming from. Maybe you get a ton of visitors from Brazil, and so maybe you want to localize your mobile app in Portuguese. Maybe you have a ton of users using Mozilla, like, 4 or something, and it's breaking. These are things you need to know to run your business. And if you have 1 million or 1 billion lines of logs, those types of insights are not easy. You can't just use, that summer intern that you got who wrote that Python script for you to parse your web logs. That doesn't scale. We've all learned this the hard way. There comes a point when you have too much data that is easy to process. And so in this case, if I wanted to run across 1 billion lines of logs and to find out what is the most popular user agents, or how much traffic is taken up by 404s, do I have a bunch of dead pages in my mobile app or my website? That's the kind of stuff that EMR can help you do really easily. And that's the kind of insights that we'll actually look at today. So those are some simple but important business problems that we will solve in real time today. So let's push some logs up. Again, you can download the log. I put it up on my S3 bucket there. So you can do this whole thing. Okay, so I'll just fire up Python here. Whoa. Okay. 1 second. Oh, sorry about that. Live demo. I'll just have to do another 1 second. There wouldn't be a live demo without the credential problem. I just don't want to put my credentials up on the screen, hence the hidden thing. I did that last time. It's amazing how fast people will figure that out. All right, let's try this again. There we go. So by the way, what I had to do there is go into my credentials file, and I had changed it from default to something else for my AWS CLI credentials in preparation for the demo. Anyway, what you're seeing here is the important part. And now you know this is a real demo. I'm pushing log lines. And this is real big data. This is an imitation of a fleet of web servers or application servers of some kind. And this is an imitation of people hitting your app. What you're seeing here, all this stuff flying by, is 32,000 lines of people, of users. Actually, usually it's not people, it's usually bots. But bots and people hitting my application. That's what this is. Okay, so let's just hide this for a while, because that's going to make you all dizzy this early. Put another one up there instead. And we'll have to wait about 60 seconds now. And while we're waiting, let's talk about the next thing. Why do we have to wait 60 seconds? Because if you were paying attention, what I'm doing is sending it into Kinesis Firehose, and when I created the stream for Firehose, I set a buffer time of 60 seconds. So it's going to collect those lines for 60 seconds, and then it'll batch them together, gzip them, and push them into S3. So let's just hang out for 60 seconds and talk about Spark. So Spark is amazing because it's fast. It's a general purpose framework to do a lot of stuff. Most people use it for batch data processing, but there's also Spark streaming. If you've attended our Big Data Bootcamp, you'll know we do a lot of that. There's a graph database, GraphX. There's machine learning. It's a very powerful and evolving framework. And you install Spark on a cluster of some kind, and you need something to manage that cluster and to distribute resources. So if you have data, you need something to tell Spark where to go to find that data and how to work. And that's what, for example, Hadoop is. Hadoop is, you can run Spark on Hadoop, and we're running Hadoop on EMR. But you can also run the Spark standalone cluster. You can run Spark on Mesos. You can run Spark on any kind of cluster management tool. I'm just choosing to use EMR and Hadoop because it's easy, and it's integrated in the AWS platform, and it's my sort of platform of choice. But you have choice here. Spark is, think of it like an application that runs on a distribution, and I'm running it on the EMR distribution of Hadoop. So why is Spark fast? Because it takes better use of memory. Like I said, it does a bunch of processing. We don't have time to get into all the details of Spark. If you're interested, come find me after. But long story short, I used to give a demo like 2 years ago where I did a data processing. It would take like 25 minutes. And you'd sit there and it was super boring because MapReduce was designed to be scalable but slow. Spark can do that same thing. In fact, we do a version of it today in about 5 seconds. So it's a lot faster, orders of magnitude faster. Now, the great thing about Spark is that who knows if it's going to stick around. Everyone thought MapReduce was hot like 5 years ago. Now everyone's talking about Spark. And just when you think you're wrapping your head around Spark, now there's Flink, and everyone's talking about Flink now. It's the same in the streaming world. Everyone was talking about Storm, and then Twitter, who created Storm, turned around and said, oh, no, we're done with Storm. We have Heron now. Everyone's like, oh, man. So just when you learn one thing, you got to move to another. But if I'm trying to reinforce anything today, it's that the patterns don't change. Sometimes the languages change a little bit, like Java to Scala or Python. But end of the day, what you're trying to do remains fundamentally the same, which is why I like working with higher level frameworks a lot of the time, like Hive or Spark SQL. It makes things kind of easy, and you let someone else take care of the heavy lifting so you can get your job done, which we often forget in this world. We have a job to do. So Spark SQL makes it easy to run Spark jobs. I mentioned Hive before. There's also, my favorite one is Pig, which is another way to interact with data, another sort of framework and language. And Pig on Spark is called Pork. Really great naming. But Spark SQL, essentially, you can write SQL, select star from Matt, where big data equals fun, and it gives you results. Most of us here know how to use SQL. Many of us here don't know how to write the equivalent in Scala, right? So Spark SQL prevents you from ever having to learn Scala, which for most of us is a good thing. And it takes care, it translates that SQL into a Spark job and goes and runs that Spark job. Just like in the old days, like a year ago, when you wrote a Hive SQL statement, it would translate that into a MapReduce job and go run it. So that's what Spark SQL is, and that's what we're going to use today. We're actually going to do a bit of both. We're going to do Spark and Scala, and then I'm going to show you some SQL statements as well. And lastly, Zeppelin. This is me killing time while the data loads up. Zeppelin is the web UI that makes all of this a little prettier, a little easier to use, and also so you can save it. There's nothing worse than running a bunch of commands in a screen in SSH shell and then realizing you screwed up way at the top and you forgot to set your line buffer in your terminal. You can't scroll up anymore. I mean, these are real-world problems for big data people. Zeppelin, you can actually write notebooks that you can save and export and import. And in fact, I give you a notebook to import into Zeppelin so you don't have to copy-paste all this stuff. So you can share code more easily, see the results, debug. It makes working with things like Spark a lot easier. OK, so let's see if we have anything. I'm going to have to adjust my... I just have to change my profile that I'm using now. OK, so let's check it out. What step was I on? So if all was working, which I hope so, we should have, makes it a little bigger. Yeah. So I'll show you so you believe me it's real. But remember that bucket I created? I should have showed you at the beginning that it was empty, so it's not a sleight of hand. But I promise it was empty. The MEN demo Chicago now has, remember I had the prefix to Firehose in my Firehose, and it now has these clusters. Now in this case, the 60 seconds didn't add up to a megabyte. So instead of waiting until it's a meg, it just waited 60 seconds. But we have batches of log lines. So if I switch back to that other thing that was making us all dizzy, you'll see that I'm still pushing requests in there, and the number of files in that bucket will grow as the minutes pass. So we now have streaming data, streaming from our cluster of fake web servers through Kinesis Firehose into S3. We have started to collect big data. We've solved problem number one with big data. Now what I did do, to be fair, is I did spin up in a separate account, I spun up EMR and Redshift, so I had the full data set. If we have time to do this if all 32,000 lines get up in time, we'll work off that, the real-time one. But I also have a backup so you can see a little more data, and the visualizations look a little prettier. But what we have to do now is connect to Zeppelin and connect to our to our EMR cluster. And we connect to EMR using SSH. So in this case, I'm going to connect to my, actually, no, let's connect to the one we just created. Let's live dangerously. So here we are with the cluster. It's up, OK? So remember, we spun up that EMR cluster. When it's in waiting state, that means it's available. And now it gives us an address, which is right here. Let's copy paste this. I'm sorry. They don't make this easy across the screens. This is why I use a CLI. OK, so I just copied in here. So I'm going to connect to that cluster. Now what I've done here, let me just copy it again so you can see it. Oops. Little inception. OK, if you look at this command, so it's a little messy. Let me make it bigger. This is one concept I want to make sure you understand, is port forwarding. If you're using, there's all these applications running on your EMR cluster, right? And a lot of these applications, like Spark, like MapReduce, and in this case, like Zeppelin, have web interfaces. But EMR, remember, is running in my AWS account, and those ports are not necessarily open to the world by design. I don't want anyone accessing my EMR cluster, right? So we can use something called SSH port forwarding to effectively create kind of like a poor man's tunnel. And that allows in this case, the Zeppelin port, which is 8890, that's the port of the web interface, to be exposed on my local laptop on localhost. I just arbitrarily picked 18890 because Amazon doesn't block that port on my laptop. But you can pick any port. And so using that -L allows you to forward locally exposed interfaces and ports from like the machine that you're connecting to and expose them on localhost on your machine. So it's a great way, without having to set up fancy VPNs or anything like that, to access stuff. So I have connected to this cluster and forwarded that port. So now, if I have some luck, I should be able to see Zeppelin. And I'm actually looking at the Zeppelin interface on my EMR cluster. So this is a new Zeppelin. So I guess I'll import it rather than do a bunch of copy pasting. That's not fun for everybody. Can't see. Just call it Chicago. Now I have exported the Zeppelin notebook just so you don't have to watch me copy paste a ton. But I could have just created new notes. So here we are. This is Zeppelin. And the first command that we're looking at is going to start interacting and processing our data. So just a reminder where we are. We're pushing data into Kinesis Firehose. It's getting persistent into S3. And now we're going to use EMR with Spark to interact directly with that data in S3. Now, we didn't really talk about that yet, but this is where it gets really exciting. Because with Redshift and with most databases, you need to load the data into that database first to interact with it. But if you're using Hadoop and with a framework that supports S3 as a data source, like MapReduce on EMR or Spark, you can actually interact with the data, manipulate the data directly on S3. You don't need HDFS. You don't need to load it into some intermediary. So it's a great fast way. You can spin up an EMR cluster that can go away when you're done doing the analysis, and your data stays safe on S3. You can transform that data in place on S3, wipe out the cluster. Now, if you think about this, this is enormously powerful, because you can have petabytes of data on S3, and when you need to analyze it, you can spin up a cluster, an EMR cluster, do whatever you got to do, exploratory analytics, data processing, changing it, and then wipe that cluster out. And you only pay for the time that you had that cluster up. And the data stored in S3 is super cheap. Now, contrast this to a on-premises data warehouse. You're paying sometimes millions of bucks to have the compute and the storage coupled together running on premises, and you have to keep them there. It's not like you can throw out the racks of servers when you don't need to do the analysis. That's not true. But with EMR, when you have all this data and your CTO wakes up really angry one day and says, give this to me by Monday morning, you can just spin up that cluster, hit that data, shut down the cluster, and still meet your budget. So by decoupling the storage, keeping the storage in S3 from the compute, in this case EMR, it gives you that cost, that value for money, that flexibility. So we're going to use a little Scala. I wanted to use real Scala to show that it's actually an easy language and anyone can pick it up. And we're going to do something very simple. We're going to load in, or not load in, we're going to create an object from S3. An object in Spark terminology is called an RDD. And it's going to point to that location that we're currently pushing data to in S3. It's not going to pull the data in. That's actually going to act on the data there. We're going to count the amount of lines there. And we're going to print one of the lines. And then we're going to do some basic data manipulation. In this case, we're going to split the log up. So let's check it out. Now, I loaded it, so it already sort of did that ahead of time. But I'm going to do Shift-Enter to run this. And this goes off and runs the Spark job. And it's going to do a count. Well, it looks like all of the logs are already in there. Let's just check while we're waiting here. Oh, well, close enough. So now it's running, and it's actually iterating over those gzip files in S3. And in this case, we're counting all the lines and seeing what the total count is. Now, if you were to do this in MapReduce, we'd be sitting here for another 20 minutes. But with Spark, even on a single node, access denied. Whoa, OK, sorry. Oh, because I have the wrong bucket. That's what I get for copy pasting. Chicago is where I put it, right? Try to keep it human. Let this run. There we go. It seems to be working now. OK, cool. So far, we have loaded in 15,000 lines. That makes sense. There's about 39,000 total. And if we look at this, I asked it to show me the first line of S3, just so we can see what's actually the first line of the first log inside that gzip file, and then to actually do some parsing. And this is the result of the parsing when things are parsed out. Nothing fancy. I just wanted to show you that we can access the data in S3 and do a count. And if you think of this, in just a few seconds there, after I fixed the name of the bucket, we counted 15,000 lines of logs in S3 using a single node or two-node EMR cluster in just a few seconds. Without loading the data into a database. There's no index, there's no database here. It was actually reaching into the files on S3 and doing a line count. And that's pretty powerful. So let's do something real. So rumor has it that not all logs are clean and that there's a lot of junk that gets introduced into logs. What more often than not what happens is log formats are all over the place. Some of them are JSON, some of them are XML, some of them are tab delimited, some of them are CSVs, some of them are just Bob, who you hired and just threw some stuff in the bucket that he shouldn't have. And if you try to load all that stuff into a database, your database will choke, because your relational database. Because your relational database will say, well, hold on. I have column A, which is host, column B, which is refer, column C, which is whatever, like, oh yeah, HTTP status code. And Bob loves noodles, and they don't fit into the column. And so you need a way to normalize, to clean your data, and to potentially pitch out some of the data, like Bob's data that isn't good. In this case, I want to do some data manipulation, maybe to drop some of the data I don't need. Remember I talked about omniture logs? And they have like 90 columns in some cases. I only need like 10 columns of data to derive the value that I want out of those logs. So I want to drop the rest of the data. Maybe I need to pick some of the columns out. So you could hire that summer intern to write that Python script to do a regular expression, or maybe in Perl or something like that, but that won't scale. What instead you can do is run EMR and use something like Spark, and in this case Scala, which is really good at doing essentially replace alls and text replacements and field manipulation. So in this case I'm doing something simple. I'm taking out commas, and it looks like spaghetti code on the screen here, but if you look carefully, it's really not that complicated. I'm just doing basic string manipulation. And if you've ever written a regular expression in your editor of choice, this should make sense. So let's do that. Sorry, that's a little small, make it bigger. So it's the same code I have there. And what's cool about this is that A, it just finished already, and B, I'm setting up the transformations such that it'll go then and apply that transformation to the files in place on S3. So it's kind of loaded the stuff it needs to do in memory. You can do a bunch of operations in memory, and then you can tell it to write back and treat S3 like a database. So it works very, very quickly. Again, if I was to do this with MapReduce, it would actually have to go off and do it, and it would take like 20 minutes. With Spark, it's really fast. So now I'm going to create, now that I've done my data transformation, I did something really simple. You would probably have to do a lot more. Or maybe not. Maybe you just need to remove every third comma from your text file. You could write that in 2 lines of Scala. Now I'm going to create a table, which in Spark parlance is called a data frame. And then I'm going to actually apply the transformation. So I'm just doing basic text manipulation here. So let's do that. I don't expect you to all read this code. You can read it on your spare time at home, but I wanted to make this slide deck complete so that you can, so even if it doesn't make the nicest show, when you take it home, you have all the code you need in the slides. So again, this is just basic string manipulation that we're doing to normalize our data. And why are we normalizing our data? Because we're going to put this data into Redshift. And Redshift is a structured database. It's a data warehouse. So I need to make sure that my data maps up to the columns of my table in Redshift. And that's what I'm doing. OK, so let's go back and actually do this. So here we go. Let's create the table, and we'll apply the transformations. Pretty fast. Well, I don't need to drop it because it's a new cluster. Now, this is when we apply the transformations. What that actually means is that we're going to take all the transformations that we've done in Spark in memory, and we're going to write them back into S3. So we're going to take the data and essentially funnel it through Spark back into S3. And in this case, we're doing back into a separate folder, if you will, or prefix into S3. So we do that by creating an external table. Now, those of you who are paying attention will notice that I've done something here. I've switched to SQL. Oops. Oh, that bucket's wrong. Thank you. Someone is paying attention. Chicago. That's where we are. There we go. So I'm using SQL now. So now we're using Spark SQL to interact with the data. I could have done the data transformation in the earlier steps in Spark SQL, but SQL is not a great language for doing data transformation. It's inefficient. If you needed to do the same data or text transformation that I did in those previous steps, it would have been way, way longer in SQL. So even if you're comfortable with SQL, it actually helps to learn another language like Scala or Java. Scala is much more condensed than Java to learn to do the data transformation. So there it's created. Now we're just going to set some options with Hive, and all this is doing is just telling Hive to split the files up and to compress them when it writes back to S3. This is the kind of thing you Google and copy paste. So if you're reading quickly here, I'm just telling it to use gzip when it writes out and to not get too stressed about the data. And now we're going to write it. OK, so this will run. And let's flip back to the console for a second. So if I go into S3, here we have Firehose that we created. Let me make this bigger so you can see it. Here we have Firehose, and this is where the data that we were writing through Firehose from our fake web logs was going. And you'll see that all the packages there now. There's probably all 39,000 lines now. And Oh, this is actually Chicago. This is the she one. Sorry, I should go to my real one. There. We're using the one we're doing in real time rather than use the pre-baked one, just have some fun in the morning. So here's Chicago. This is the one we actually did today. Firehose, 2016, make it bigger. That's today. And here's the little bundles. And if we go back to Chicago, access logs processed, this is what we're writing right now from Zeppelin and from Spark. It's in the middle of writing them. And these little gzip files are the transformed data. So it's taking those transformations, those text manipulations that we did to normalize the data such that it'll match up with the way the schema, the table that we have in Redshift. And now what we're going to do is take these files and load them into Redshift. Now that we have normalized the data, we've cleansed the data, we've processed the data, it's ready to get loaded into our database. We're in the home stretch. This is the steps I just took to write. Before we actually load it in, though, I wanted to show you that you can actually query the data in Spark as well. And the line between data warehouses in sort of the Spark world and Redshift is actually increasingly blurry. You can do a lot of data warehouse stuff in Spark, in Hive, in Flink that you can do in Redshift. It's just that Redshift is more like mature. It supports a richer SQL syntax. Using SQL for true, like, you know, the data warehouse guy that you hired in 1979, and like he has his crazy SQL statements that he's written that do these amazing insights for your business. They will likely not work on Spark SQL today. They will work on Redshift. Redshift is really designed for the enterprise-grade SQL. But if you're doing exploratory analytics, Spark and Spark SQL is amazing. And what's exploratory analytics? It's where you don't know what you have yet. What if you inherit a giant data source or a giant data set and you don't know what the structure is? You don't have the luxury of just loading it into a Redshift because you don't know the schema, you don't know what the columns are. So doing exploratory analytics on Hive or on Spark SQL is amazingly powerful. And soon we'll release Kinesis Analytics, and you'll be able to do analytics, SQL-based analytics on your data in your Kinesis stream as well. But in the meantime, we can do this. We can use Spark to do basic things like how much data do I have? What does it actually look like? What tables do I need to create in my database? What transformations do I have to do to normalize this data? And that type of exploratory data where it doesn't matter what format the data is in because Spark doesn't care, it's not structured, is enormously powerful. And not only that, but it can do it on top of any data source in S3. So someone hands you an S3 bucket, you can use Spark SQL to kind of look into it, check it out. So let's do that. So that oh yeah, so it's loaded. It's now sitting in S3. So let's do a count. I don't know how many, because we're using the real demo here, I don't know how many lines actually made it in before we ran this. Oh, well, we'll see in a second. It's running. There's 39,000 total. If we were to do this in the full data set, let's see how many made it in. Is that little guy still running? It's still going, so not all 39,000 will be there. But we still, not bad. Using the McCormick Place Wi-Fi, we managed to get 15,000 log lines in the time I was talking here. So that's what's actually in S3. That's actually what we pushed. And let's do a little exploratory analytics. Let's do something more. Let's actually see the data. See how fast that was? So I just ran that query, and it showed me the lines in the data frame or in the table. So this is the actual data now parsed into columns. Well, let's do something more real. Let's actually do an analytic type thing. Oh, sorry. So in this case, I'm actually doing some kind of a real query. Let me make that a little bigger for you. Oops. So select request path, take a count from access logs where response code is 404, and give me the top 3. If you speak SQL, that's what I just asked. So this is a really simple thing. If I run a website and it has 1 billion pages, because I'm in a retail company that you may know, some of those pages may have dropped off the radar, and I want to find out what is throwing 303s. Well, it turns out that I have missing fave icons on 134 pages. So right there, I have an insight. And this is admittedly a bit of a trivial one, but that's something. You're getting misses on fave. There's fave icons missing, the little logos for websites, on a bunch of my pages, and that's not a good user experience, maybe. So it's a little, because I've zoomed in there, it's all squished up. But what this is showing you is that Zeppelin, and combined with Spark SQL, you can actually do basic visualizations in Zeppelin. And you can do SQL exploratory analytics without even firing up Tableau or QuickSight or whatever. Maybe you can answer that business question that your CTO is pressuring you without ever leaving Zeppelin, without ever loading into Redshift, without ever going to Aurora. It's pretty powerful. But most business problems are not solved by Matt's select statement like this. This is a pretty simple statement, and once you get into the heavier stuff, you need to move to that data warehouse. So let's do that. So last but not least, okay, I showed you those in S3. We're going to analyze the data. So that cluster, remember that cluster way back when we spun up? Let's check it out. It's up, it's available. There it is. So let me grab the name, of the cluster. Make sure that I have, let me get the real one we spun up. Well, that's it. Okay, so it's publicly available. I should be able to connect to it. I'll do another window here. You can hear a pin drop in here. Okay. Here we go. So I'm going to use, again, because you can probably tell I like the command line. Now you can use any tool. Some people use, I really like a Agility Workbench for Redshift. If you like a GUI or SQL, what's called SQL Workbench for Mac is okay. Pretty much anything that can talk Postgres, but ideally can work with the custom Redshift drivers, connect to Redshift. In this case, I'm just using the Postgres command line client, pSQL. That should be it. If this doesn't connect for some reason, I'll just use the one I have backup. I've lost track now, which is which. Might be blocking me on the Wi-Fi. 1 second. Oh, I had the wrong host name, sorry. Or it's not connecting. Hope the Wi-Fi is not blocking me today. Let's stop the other guy. Maybe that's taking up all my... Oops, shoot. Okay, sorry guys. We could be having a firewall issue. Let's try one more time, and if not, we'll just go straight to QuickSight. Okay, well, while we're waiting for that, my apologies. Let's go to QuickSight. So there wasn't much to show you on the command line anyway. I was just going to do a SQL statement. But what I wanted to show you was that connecting to Redshift is easy and that you can use the Postgres client and just issue SQL statements against it. So this is QuickSight, a rather simple UI. And it's designed for analysis, for doing data visualization. And what QuickSight does is you can either analyze directly the data sources in locations like Redshift, or you can load it into its high-speed in-memory data storage called Spice. So depending on what types of visualizations you're doing, you can tell stories where you put together a number of different visualizations. If you need those visualizations to be really high speed and changing in real time, it makes sense to load that data into Spice. But for QuickSight, for our purposes, just using it as a data viz tool to look at Redshift is perfect. So in this case, I've set up a similar visualization for Redshift. This is talking to Redshift, and it's doing something similar to what I did before, where I've set up a query that essentially asks for all access logs, the request path, similar to the one we ran in Zeppelin before. I put in a filter where the request equals 404. We could change this just to do 200 to see what is the top pages, where are we getting the most HTTP OKs. And there we go. Let's make this so we can actually see it. So Oh, Alexa. It's not the Alexa that we all know and love that I have in my living room, but it's the web ranking tool. But it's a widget that's getting hit a lot. So we see 800,000 hits, the response code 200. So we're getting an HTTP OK for 200 on Alexa for our widgets. RSS is also really popular. Now this is an insight. It turns out that we have 502,000 people using our RSS feed, or at least 502,000 hits in the time that these weblogs represented. So that's a decent business insight. We should keep the RSS up. So these are pretty simple graphs, but you can use QuickSight. I just wanted to show it to you quickly to build any number of data visualizations against the tables that you have in Redshift that you can load into Spice or hit directly in Redshift. It's a quick and easy way to build data viz and to create stories for your business that allow them to see the insights in your data. Oh, it was just slow. OK, let's do some Redshift. We'll just backtrack for a second. So here we go, almost done here. So I'm going to create a table, just like I would in SQL. Oh, let's drop it. So there, I created a table, and this table corresponds to the fields that, remember when we did the data transformation using Spark? So if I had selected or used the text manipulation to pull out the fields I wanted, this is what it's corresponding to. Redshift is a well-structured data warehouse. I didn't really optimize my column sizes, don't judge me. But we have a distribution key, which distributes the data across the cluster. In this case, it's a single node cluster, so it doesn't matter that much. And we're using request time as the sort key. We don't have time to get into the nuances of optimizing a data warehouse, but just take this takeaway. Choose your distribution and sort keys. It's important. Choose them well. Because if you choose them properly, your data gets distributed across the data storage in your cluster in such a way that your queries will run faster. Likewise with sort keys. So read up on distribution keys and sort keys. It'll save you tons of seconds waiting for queries to come back. OK, so now let's actually do something. Let's load data from S3. So remember, we use Spark to Now, if you copy that access key, don't worry, I get rid of it right after the presentation. Now, that was not a joke. That was how fast Redshift loaded 15,000 rows from our table into our database. So what we've done is we've taken the transformed data that we transform with Spark, and we've loaded it into Redshift. And now we should be able to query that data directly in Redshift. So let's do just some simple queries just to show you that it's working. So there we go. Here's a count of different response codes. So we're getting a lot of 200s on a lot of people, more people visiting, some insights here, more people visiting our site on July 21st than July 22nd, and a lot of 404s that we probably have to clean up and some other weird errors that we probably have to look into across our app. So there we have some business insights that our coders can go fix. Let's just do one or two others just to check it out. This is the one I was running out of Spark. So we have 290 in the new data set that have a 404. And last but not least, give me some business insights from that. What is causing all those 404s? The fave icon. So if we go and fix that one, we'll reduce our 404, our error count effectively for web requests dramatically by just fixing that one fave icon or adding it to our top level tree. So what I wanted to show you before I was waiting for Redshift and the Wi-Fi to connect was that this is great, but if you pull up a terminal and show that to your CEO, they're going to not smile. You want to show them a nice graph, you want to show them insights, and that's where QuickSight comes in. So we'll end with this again. So QuickSight takes what I just showed you in that black and white console and turns it into something pretty, and you can add visuals, you can have multiple graphs, and you can take that data that we've extracted, that we've stored, that we've collected, that we've transformed, and turn it into a real business insight for whatever you are doing. And that's what I want to show you today. In real time, with just a couple glitches, we built an actual big data application that could scale to 3 billion rows. I encourage you to download the slides. I also encourage you to use the mobile app to review the session. Your feedback is very important. And we also have a lot of time before the keynote, so if you have any questions, feel free to come up and ask me afterwards. Happy to answer any questions you may have. Thanks for your time today, and have fun at the summit.